Mercury. We start with Mercury, the first planet in the solar system and the smallest of them all. It sits about 58 million kilometers from the Sun, so it receives roughly 7 times more solar energy than Earth. And Mercury doesn't have a real atmosphere to protect you. It only has an extremely thin exosphere. So basically, sunscreen isn't going to solve this one. During the day, temperatures can reach around 430 degrees Celsius. At night, they can drop to about minus 180 degrees. Mercury is basically stuck between an industrial furnace and a cosmic freezer. The reason is simple. Its extremely thin atmosphere cannot retain and redistribute heat, and Mercury rotates very slowly. A full solar day from one sunrise to the next lasts about 176 Earth days. So if your plan is, let's just wait until nighttime, you may want to reconsider. Its surface is covered in impact craters. One of the most famous is the Caloris Basin, more than 1,500 kilometers wide. No breathable air, no suitable atmospheric pressure, and almost no real protection from solar radiation. From far away, Mercury looks like a quiet rock. Up close, that rock has a lot of problems. Venus. Venus is similar to Earth in size and mass, which is why people sometimes call it Earth's twin. But apparently this twin made some very different life choices. The average surface temperature is around 465 degrees Celsius. The reason is its incredibly dense atmosphere, made of about 96.5% carbon dioxide. This creates an extreme greenhouse effect. On your way down to the surface, you would pass through clouds containing droplets of sulfuric acid. And if you somehow reach the ground, the atmospheric pressure would be about 92 times Earth's sea level pressure. That's roughly comparable to the pressure found 900 meters beneath Earth's oceans. Venus also rotates incredibly slowly. One rotation around its axis takes about 243 Earth days, but one orbit around the Sun takes only about 225 Earth days. Yes, a Venusian year is shorter than its rotation period. Venus decided astronomy wasn't complicated enough. Extreme heat, crushing pressure, and an atmosphere you cannot breathe. The planet's name sounds romantic, the travel package does not. Mars. Now we reach Mars. The star of science fiction movies and the permanent winner of the phrase, maybe humans will live there one day, maybe, but definitely not in a t-shirt and jeans. Near the equator, daytime temperatures can occasionally reach around 20 degrees Celsius. Sounds nice, right? Wait, the average temperature of Mars is about minus 63 degrees Celsius, and during winter near the poles, temperatures can fall below minus 120 degrees. Mars has an extremely thin atmosphere. Its surface pressure is less than about 1% of Earth's sea level pressure, and the atmosphere is mostly carbon dioxide, so you need a pressurized environment and a complete life support system. Then there is radiation. Mars doesn't have a strong global magnetic field like Earth, and its thin atmosphere provides much less protection. Space missions have measured radiation levels far higher than those normally experienced on Earth's surface. And then come the dust storms. Some Martian storms can expand across enormous areas and occasionally cover most of the planet for weeks or even months. Because the atmosphere is thin, the wind doesn't hit like a terrestrial hurricane. But the dust can reduce sunlight and interfere with equipment and power systems. So to live on Mars, you need a sealed base, proper pressure, oxygen, water, energy, and radiation protection. After all that, Earth's rent suddenly doesn't sound so bad. Jupiter. Now Jupiter, the largest planet in the solar system. Its volume is more than 1,300 times that of Earth, and gravity near its cloud tops is roughly 2.5 times Earth's gravity. But we have one small problem. Where exactly are you going to stand? Jupiter doesn't have a clearly defined solid surface. It's a gas giant made mostly of hydrogen and helium. So congratulations, you reached the planet. The floor was not included. Jupiter also has an enormous magnetic field that creates extremely intense radiation belts. If you entered its atmosphere, you would encounter clouds containing compounds such as ammonia. Near the reference cloud level, temperatures are around minus 145 degrees Celsius. Winds can reach hundreds of kilometers per hour, and the deeper you go, the pressure and temperature continue to rise. Matter becomes increasingly dense. Deep inside Jupiter, scientists believe hydrogen enters a state called metallic hydrogen, where it can conduct electricity, and we can't talk about Jupiter without mentioning the Great Red Spot. A gigantic storm that has been observed for centuries. Today it is still roughly wider than Earth. On Earth, when a storm arrives, we close the windows. On Jupiter, the storm itself is bigger than your planet. No solid surface, extreme radiation, and pressure that keeps increasing as you descend. Jupiter isn't really a landing destination, it's more like a physics lesson that decided to become a planet. Saturn. Saturn is beautiful.
Rings, soft colors, and pictures perfect for a desktop wallpaper. But don't get too excited, its rings are not a solid disk. They are made of enormous numbers of pieces of ice, rock, and dust orbiting the planet at high speeds. In many regions there is plenty of space between the particles, so the rings are not a solid wall of rocks like some movies suggest. Saturn has a huge number of known moons. One of the most famous is Titan.
Titan is larger in diameter than Mercury, although it has less mass. Saturn itself is another gas giant made mainly of hydrogen and helium. It has no traditional solid surface. In parts of its atmosphere, winds can exceed 1,000 kilometers per hour, and at the North Pole we find one of the strangest sights in the solar system, Saturn's famous hexagonal storm, a gigantic cloud system shaped roughly like a hexagon and stretching tens of thousands of kilometers across.
Even Saturn's storms decided to study geometry. As you move deeper inside the planet, pressure and temperature increase dramatically. Hydrogen becomes liquid under pressure and enters even stranger states deeper inside. Models also suggest a dense interior region rich in heavier elements. Basically, Saturn is fantastic for photography, but booking 3 nights? Let's stick with the pictures. Uranus? Uranus is one of the 2 ice giants.
And the first strange thing about it is its axial tilt. Its rotation axis is tilted by about 98 degrees. So the planet basically rotates while lying on its side. Apparently, Uranus takes relaxation very seriously. A day there lasts only about 17 hours, but a year lasts around 84 Earth years. If you celebrate one birthday on Uranus, it may literally be the party of a lifetime.
Its atmosphere is made mainly of hydrogen and helium, with methane helping give the planet its blue-green appearance. Uranus is also one of the coldest planets. Temperatures in its atmosphere have been measured near minus 224 degrees Celsius, but deep inside, things become much stranger. Under enormous pressure and heat, models and experiments suggest that carbon-rich compounds may break apart. Carbon could then form diamond-like structures and fall deeper into the planet. Yes. Diamond rain, unfortunately, delivery to Earth is not available. And the so-called internal ocean of Uranus isn't a normal ocean where you can go swimming. It is an extremely hot, high-pressure mixture of water, ammonia, methane, and other materials in unusual physical states. From far away, Uranus looks like a quiet blue dot. Inside, it's a physics and chemistry laboratory that never takes a day off. Neptune, and finally, Neptune. The most distant of the 8 planets from the Sun. On average, it is about 30 astronomical units away. That's roughly 30 times the average distance between Earth and the Sun. So Neptune receives very little sunlight compared with Earth. But Neptune is definitely not calm. Winds there have been measured at speeds exceeding 2,000 kilometers per hour.
They are among the fastest known winds on any planet, so if a plastic bag flies out of your hand on Neptune, don't bother chasing it. Like Uranus, Neptune is an ice giant. Its atmosphere contains hydrogen, helium, and methane, and it has no clearly defined solid surface. The deeper you travel, the denser the material becomes. Pressure and temperature continue to rise. Deep inside, models suggest temperatures of thousands of degrees Celsius. Scientists also believe conditions may allow dense, diamond-like carbon structures to form inside Neptune. And here's another strange fact. Neptune releases far more internal heat than the energy it receives from the Sun. This internal heat helps power its active atmosphere, massive storms, and extreme winds. From the outside, Neptune is a beautiful blue sphere. Inside? Pressure, heat, and insane winds. Neptune is excellent as a picture, terrible as a home address. After this entire journey, notice something. Mercury swings between extreme heat and cold. Venus is a furnace under enormous pressure. Mars requires an entire protected base just to survive. Jupiter and Saturn have no traditional solid surfaces. And Uranus and Neptune are strange ice giants with extreme internal conditions. Then we return to Earth. Liquid water, a suitable atmosphere, pressure that allows our bodies to function. An important protection provided by Earth's magnetic field and atmosphere. Among all these extreme worlds, there is only one planet we know for certain supports life. And the interesting part? You're watching this video from it right now. So after traveling across the solar system, we can say one thing. Earth has problems, sure, but at least it has a floor.